Alright, grade 11s, so we are going to be looking at arithmetic sequences, and we are continuing our journey through sequences and series, and now we get to this really straightforward, beautiful topic, and we need to first of all discern what makes a sequence arithmetic. Because as we continue our journey through the section, we're going to find that there are a few different types of number patterns or sequences, and we need to be able to decide what type of sequence are we looking at. So I think from this point, I want us just to look at the general term of an arithmetic sequence, or the fancy schmancy word that we use is the nth term. So the nth term, or the general term, is Tn equals A plus n minus 1 times d. And already I know a few of you are going to be like, oh my goodness, Claire, what is going on? This looks intimidating and scary, but actually it is super easy peasy. So let's just write down what all these different letters mean in this nth term. So the letter A represents the first term in the pattern or the first term in the sequence. The letter D, so D is super important. We call this the constant difference, right? And when I say constant difference, what I mean is we will be adding or subtracting. So it's very important, subtraction as well. You will add or subtract the same amount between consecutive terms, right? Which you will see when we get to our first example. So we'll add or subtract. And another way of writing this, or not writing this, but thinking about it, is this notion over here. So T2 minus T1 equals T3 minus T2. So what I'm saying here is term 2. So term 2 minus term 1, if I subtract or add those two together, it will be the same as term 3 minus term 2. So again, now when we're just talking about it, it seems a little bit confusing, but when we go through our worked example, I promise it will make lots of sense. All right, so we still need to deal with this guy over here. So n is the position of the term, and Tn represents the value of a term. All right. So here's my general term or nth term for an arithmetic sequence, where Tn represents the value of a term, A is the first term, n is the position of the term, d stands for the constant difference. And the way I figure out d, the constant difference, where I'm adding or subtracting the exact same amount each time, I can use this nifty little trick over here. Term 2 minus term 1 is equal to term 3 minus term 2. So let's get down to an example, and you're just going to see how super basic this is. So if I'm given the pattern, let's go 1, 3, 5, 7, 9, dot, dot, dot. So when I say dot, 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 what I mean is that this pattern now is continuing. It can continue indefinitely. Sometimes it does come to an end, but the dot, dot, dot is just saying, okay, so this pattern keeps going. So for example, the next term in this pattern would obviously be, so what do you think it would be? We've got to figure out now, what am I adding or subtracting each time to get to the next term? So if I see the difference between 3 compared to 1, I can see that I am, what am I doing? This looks like I'm adding 2 to get from 1 to 3. I'm adding 2 to get from 3 to 5. This keeps happening. So I've figured out that my constant difference, represented by the letter D, in my nth term must be 2. And using this little trick over here, I can now really illustrate to you what I'm meaning by this. So I'm going to write here, this is term 1, term 2, term 3, term 4, term 5, and remember this carries on. So let's look at this third term. All right, so the position is 3. It is the third term. Its position, it's the third term, and its value is 5. So it's really important that we understand the difference between n and tn, because this is what really catches people out when we get to our fully worked questions. So if I look at this 5, it is in the third position and it has a value of 5. The number 9, so 9 is in the fifth position, it is term 5, and it has a value of 9. The difference between each term is that I'm constantly adding 2. And if I wanted to use my trick, term 2 minus term 1 equals term 3 minus term 2, well, if I went 3 minus 1, is that the same as saying 5 minus 3? Of course it is. All right, so this little bit that I've done here, this is not working that you need to show your teacher or whoever's marking a test or an exam that you're writing. This is margin work. Or the thing is, this was really easy. We could just do this by inspection. I could by inspection see that I'm adding 2 each time, right? So this here is not necessary. But this tool is going to be super useful when we do get to more tricky and complicated questions, which will come later on. So I want you to remember this and hold on to it. It's very important. Okay, so there's our pattern. I haven't even said what our question is going to be. All right, so my first question is going to be, find the nth term. Let's actually just start with something basic like that. So I want to find out for this pattern, 1, 3, 5, 7, 9, ... What would the general pattern be to describe this sequence? And you must be thinking, like, why is this even important, Claire? Like, what's the point in finding the nth term? Because, I mean, I can already figure out, I'm just adding 2 each time, right? So if my question was, what's the next term in this pattern? You'd say, well, duh, 9 plus 2, 11. And I'd say, all right, what's the next term? You'd go, well, 11 plus 2 is 13. That's easy. Imagine I said to you, okay, well, what's term 100? Can you imagine having to now keep adding 2 up until you get to the 100th position? That would take forever and is a bit of a waste of time, I must admit. So instead of all of that, I just want to find out what is the general term, the nth term, that is going to represent this number pattern over here. And now we have to come back to this idea at the top. This is the general term for all arithmetic sequences, and now what will happen is my A and D will change according to the given sequence. Okay, so if Tn equals A plus n minus 1 times D, Tn equals, so what did we say A was? A was the first term. In this question, the first term's value is 1. So it's going to be A plus n minus 1 times. D is the constant difference. We've already determined that our constant difference is 2. All right, so you've answered the question. Isn't that easy? What some people do from this point is they might rewrite this and multiply out the bracket and add up like terms. So they'd leave this as 2n minus 1. But if you come to this step and you stop here and that's your final answer, obviously that's 100% correct. Some people like carrying on to this point because it would help with questions that happen later on. Okay, so I think after this first example, we should all be feeling pretty good because, hey, this is quite easy. Right, so we're going to continue now. I'm going to move that away. Look. Let's look at a second example. And let's get a little bit more in depth with this one. Okay, so if you are given the sequence, what should we make our sequence? So let's go -1, 2, 5, 8. Okay, so this is my sequence. My first question is determine the nth term. Right, remember that the nth term is just my fancy way of saying find the general term for this sequence. My second question will be, what is the value of, let's say, term 25? So what is the value? We need to go back and think about the letters from our general term that we started off with. Which letter did we associate with value? Yes, we said that Tn represents the value. So we are going to be solving for Tn in this question. My follow-up question, the third question, will be, which term is equal to 80? So let's think carefully about this again. Which term is 80? So what I want to do is I want to work out in which position does a term have a value of 80. So in this question, we will be solving for n. All right, so remember earlier I said people are going to get muddled between when am I solving for n and when am I solving for Tn. So now we're going to see when that happens. I'm just going to actually write the general term up here again, just so we can have it on our screen. All right, so remember that this is our general term for all arithmetic sequences. We now need to adjust this according to this pattern over here. All right, so to answer our first question, Tn equals, all right, so remember it's a plus n minus 1 times d. I need to work out a, and that's super easy. It's term 1, which in this pattern is minus 1 plus n minus 1 times d is the constant difference. So grade 11s, ask yourself, what am I adding or subtracting each time to get to the next term? Is term 2 minus term 1 the same value as term 3 minus term 2? And of course, yes, it is. What am I adding each time? I'm adding 3. So the value of d in this question must be 3. And remember I said that if we wanted to, we could multiply out the brackets. So 3, so what I'm doing is I'm multiplying, right, the 3 onto the n and onto the negative 1. So what is it, minus 1? So therefore your general term, your nth term for this pattern is 3n minus 4. Remember I said earlier though, if you come to this point and you stop here and that's your final answer, 100%. All right, so we already solved A. Hello, easy marks. B, what is the value of term 25? All right, so what this means is, here I've got 4 terms, right? Term 1, term 2, term 3, term 4. I want to keep going until I get to term 25, obviously somewhere further along down the line. Remember I said, when we're looking for value, we are solving for Tn. So in question B, I'm going to work out that term 25. How am I going to find out what it is? So I already know that A is negative 1. Term 25 obviously has a position of 25, right? It's in the 25th place. I just need to know in the 25th place, what is the value of that number? Right, and now all we do is we multiply this out. So this is going to be -1 plus 24 times 3. Right, what's 24 times 3? 60, 72, minus 1 is 71. Or using this formula over here. So now I'm going to show you why earlier I said sometimes people prefer to simplify it like that, because now I would just simply substitute the 25 into the n, and you see that we arrive at the same answer. 3 times 25 is 75, minus 4 is 71. So we arrive at the same answer. So here I'm just illustrating to you whether you use, let me just erase this now, whether you use this formula here, right, to show the nth term, and you don't fully simplify like we did here to this step. You can leave your answer like this and always use this to then work from there. But if you want to carry on simplifying this and get to this formula, these are obviously equivalent, right? These are exactly the same. This first line here is exactly the same as the third line. So whether we use the third line, like I did here, or whether I use the first line, we see that we arrive at the same answer. So I just like giving you options, guys. I know having options is good. Makes us feel comfortable. So C, which term is equal to 80? So if I just explain this, our pattern has been going -1, or is 2, 5, 8, ... We just figured out that if I got to term 25 would have a value of 71. Now I want to know, if I kept going and I got to a value of 80, which term is that? So remember that -1 is term 1, 2 is term 2, 5 is term 3, 8 is term 4. 71 is term 5, 80 is term what? Okay, so that's what we're trying to solve for in question C. All right, so the wonderful news is we've done all the hard work already by getting these nth terms, right? So whether we're using this first line, using this as our formula, or our simplified one, either will let us get to the correct answer. So I'm going to use both just to show you, so you know I'm not just fibbing. All right, so Tn is -1 plus n minus 1 times +3. We now need to figure out in which position is 80. In which position is 80? So using that first formula, so the value is 80. Term 1 is -1 plus n is what we're trying to solve for. Your constant difference is 3. Okay, and this becomes now a very simple equation. So let's go about solving it. I'm going to add 1 to both sides. Get rid of that bracket. Okay, so this -1, I added 1 both sides. Or if you think about, yeah, just taking it over, 80 plus 1, 81. 3 times n, 3 times -1, gives me that over there. Oh my word, this is such an easy linear equation. So 84 is equal to 3n. Therefore, we're going to divide both sides by 3. What's 84 divided by 3? Quick. N is 28. All right, grade 11s. So there we actually approached and dealt with a very common, straightforward question that you can expect to get, where we determine the general pattern, we found out the value of a term, and we solve for n in our C, which term is equal to 80.